topic of this video is types of fibers. First of all, what are fibers? Fibers are linear polymers having relatively high tensile strength but low elasticity in the direction of fibrous axis. For a material to be classified as a fiber, its length must be at least 100 times its diameter. Fiber is a material in the form of thin filaments occurring in nature or produced synthetically, which are woven into a fabric. They are classified into three groups: natural fibers, synthetic fibers, semi-synthetic fibers. First of all, natural fibers. The polymers which are isolated from natural materials are called polymers. These are also known as biological polymers. They are classified into two types according to their occurrence in nature. First is vegetable fiber. They are of plant origin. Example: cotton, jute, hemp, etc. Animal fiber. These are derived from animal sources. Example: wood, silk, fur. Wool, silk, fur. Wool we know we are getting from sheep, etc. Silk and also fur. Next, synthetic fibers. The fibers which are synthesized in the laboratory from different chemicals are referred as synthetic fibers or man-made fibers. Example: polyacrylic fibers, polyamide fibers and polyester fibers. Polyacrylic. These polymers are made from acrylic acids, its homologies and their derivatives. They are as follows. First one is polymethyl methacrylate. Its commercial name are lucite, periclase, acrylate and Pepsex. This polymer is obtained by the polymerization of monomer methyl methacrylate. It is a hard, transparent polymer with high optical clarity. It is an excellent substitute for glass. Uses: it is used in contact lenses, lighting fixtures, windows, sun vision and in aircraft. Reaction for synthesis of polymethyl acrylate. So, methyl acrylate N molecules gives polymethyl acrylate fiber. Next, polyacrylonitrile. It is also known as Orlon. It is also known as polyvinyl cyanide. It is prepared by polymerizing acrylonitrile. The reaction is carried out at 40 degrees centigrade with small amount of benzoyl peroxide as a free radical catalyst. It is used as a synthetic textile fiber in clothing and carpeting. Example: reaction for synthesis of Orlon. So, acrylonitrile on polymerization gives Orlon the fiber. Polyamide. This polymer contains a side group in the main chain. The typical polyamide polymers are nylon 6 and nylon 6,6. Nylon 6. It is prepared from monomer E-caprolactam, which is heated in a reactor to about 533 degree K in an inert atmosphere when nylon 6 polymer is obtained. It is E-caprolactam in the inert atmosphere at 553 degrees Kelvin. We are getting nylon 6 polymer. Nylon 6,6. It is most important polymer. It is obtained by heating adipic acid with hexamethyl diamine at 180 degrees to 120 degrees centigrade. Nylon 6,6 derives its name from its starting material, adipic acid and hexamethyl diamine, both of which have 6 carbon. So 4 and 6. So we are getting on the further reaction, in two steps the reaction is there, and we are getting the nylon 6 fiber. Next, polyester. This polymer have an ester group in the main chain of the polymer. The important polyesters are pterygium and glyptol. Pterygium is also known as dacron. It is prepared by heating ethylene glycol with dimethyl terephthalate at 270 to 285 degrees centigrade in the presence of metal oxide. Ethylene glycol and dimethyl terephthalate on heating you will two times then this type of product, then other on reaction you are getting the polymer pterygium or dacron. Next, glyptol. It is obtained by the polymerization of ethylene glycol with phthalic acid. So, ethylene glycol and this phthalic acid on reaction on polymerization you are getting glyptol the fiber.